Hi, Katrina. Let me just walk through these two problems with you. Number 32 talks about consecutive integers. The word consecutive means one after the other. And of course, we should know what integers are. Integers are positive and negative whole numbers, but they also include 0. So if I were to start listing some integers, just arbitrarily, I'm going to start at -3. The next integer after -3 is -2, then -1, then 0, then 1, then 2, and it continues in both directions. And you're told that the smallest integer is x. Well, the next integer after x would have to be x plus 1. And you can look at my list above this to see why. Integers are always differing from each other by the number 1. If I add 1 to -3, that gives me -2. And if I add -2 plus 1, it will give me -1. And if I keep adding 1, I always move forward in the list. So that means that if my smallest integer is x, then the next integer is x plus 1, and the integer after that would be x plus 1, which would be x plus 2. So what I've written here is an expression for the product of these three consecutive integers. Now this is equal to -60, and it says that if you want to solve that equation for x, the equation can be written in the form x cubed plus bx plus x cubed plus bx squared plus cx plus d equals 0. Well, what we're going to do is just expand this. So if I expand x plus 1 times x plus 2, I get x squared plus 3x plus 2. This is equal to -60. If I then multiply the x by the x squared plus 3x plus 2, I get x cubed plus 3x squared plus 2x, and this is equal to -60. Looking at the question, again, we want it in the form of an expanded polynomial equal to 0, so I am going to add 60 to both sides and get x cubed plus 3x squared plus 2x plus 60, and then you can compare this to the template given in the question, which is x cubed plus bx squared plus cx plus d. I forgot my equals 0 here in the previous line, equals to 0. The question is, what is the sum of b, c, and d? So we are going to take 3 and add it to 2 and add it to 60 to get the answer. The next question that you asked about was number 36, and it says two of the solutions to the equation given are of the form a plus or minus root b. So I guess what we have to do here is solve this equation, and you're going to do that by using the factor theorem combined with synthetic division. So you want to make a list here of potential zeros. Remember that potential zeros of a polynomial would be numbers that are factors of the constant term. So we can try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Hopefully we don't get to 6. If you were to put -1 in here, let's just see what happens if I put -1 in. -1 cubed plus -1 squared minus 8 multiplied by -1 minus 6 gives me -1 plus 1 plus 8 minus 6. And you discover that this is not equal to 0. So then you move on to another one. Now remember, in class we did this in a very efficient manner, and it's what I would recommend, by putting the function into your calculator for y. So we have x cubed plus x squared minus 8x minus 6, and then going into our table and entering different potential zeros for x in our table, and that makes it a little bit easier. Remember, you want to set up your table to be on ask for independent. And all that means is when you go to your table, you can enter in values for x. So we put in -1 on paper, and we ended up with a number that was not 0. We ended up with 2. We could try 1. I don't believe 1 is a 0. 2 is not. -2 is not. 3 is not. -3 is. So again, using your calculator to be a little more economical with your time is a really, really good idea. What we have discovered is that -3 is a 0. So how are we going to use that? Well, if -3 is a 0, then what that means is that x plus 3 is a factor. So we've discovered that x plus 3 is a factor. There must be another factor, and we're going to find that other factor by performing synthetic division of 1x cubed plus 1x squared minus 8x minus 6 divided by, of course, x plus 3, and we put the 0 there. We move the first number down, so we're ready to go here. -3 times 1 gives you -3. 1 plus -3 gives you -2. When I multiply -3 and -2, it gives me 6. Added to the -8 gives me -2. When I multiply again, it gives me +6 with a remainder of 0, and that's good. And what that means is that the equation here is the same as x plus 3 times x squared minus 2x minus 2. So the solutions to this equation will be values of x that make either of these factors 0. I'm going to get rid of my synthetic division. Doesn't really matter. We've already got the equation. And if you were to try to factor x squared minus 2x minus 2, you would discover it's not factorable. So our two sets of equations that we pull out of this equation would be x plus 3 equals 0 and x squared minus 2x minus 2 equals 0. Now, of course, the equation on the left would give x equals -3, but when you look at the question, it says two of the solutions are of the form a plus or minus root b. So it's obviously not -3 we're after. What we're going to do is use the quadratic formula to solve the quadratic equation that's not factorable. X is equal to -b, which would be +2, plus or minus the square root of b squared minus 4ac. So what is b squared minus 4ac? Well, that would be -2 quantity squared minus 4 times 1 times -2. And that's going to give me 4 plus 8. That's going to give me 12. So we get 2 plus or minus root 12 all over 2a, which would be 2. And we can simplify that. I can express root 12 as 2 root 3. Root 12 is the same as root 4 root 3. And root 4 is 2, so it's 2 root 3 over 2. And of course, now what you can do is factor a 2 out of the numerator and have 1 plus or minus root 3. This whole thing is over 2. So now you can cancel the 2's and be left with x equals 1 plus or minus root 3, and you can answer the question. I hope that helped, Katrina, and I hope that you have a great day. We'll talk to you later.